So finishing this up, this actually is a little bit tricky, and I imagine that some of you will be confused on this. So what I want to do is, let's just go through this real quickly. So we're going to solve this equation, and we're going to solve this the same way we did in the first section. We want to get our cosine by itself if possible. So the first thing you're going to want to do here is divide by 6. So we certainly want to divide by 6 on both sides, and we're going to be left with the cosine of 2x equals 1/2, because 3 over 6 is equal to 1/2. Well, when doing this now, this is where this gets a little bit tricky, because what's going to happen is we are going to be trying to figure out what x is going to be equal to make this 1/2. And the problem is that we've dealt with this a little bit before, and we can use our inverses, but we can't use our inverses with a 2x. So what you want to do is you want to look at this more from a terms of when is the cosine of x equal to 1/2. Now 1/2 is one of our special right triangles, but you could certainly even use the inverse function to get an answer. It would just be in decimal form. We're going to use the actual right triangle. So if I were to draw out the right triangle here, and we have a cosine of x, and the adjacent side is 1, the hypotenuse is 2, that means our other side is the square root of 3. You can start to realize that because the opposite side, or because the adjacent side is x and 1, that this has to be a 60-degree angle. So that means that the cosine of x is going to be equal to 60 degrees, okay, which is also equal to pi over 3. But again, as we've been talking about this, that is only going to give, that only tells us one picture. Because what's going to happen is this is going to be equal to 60 degrees, or it's going to be equal to 1/2 at more than one spot. If we're going on one rotation around, it's already going to be there at least 2 spots. So when we draw our unit circle, we know that the cosine is positive in the top right quadrant. That's where the pi thirds is. But it's also positive in the bottom right quadrant, and that's going to be at, our reference angle is still going to be pi thirds there, but we would have to do 2 pi minus the pi thirds. Okay, so we would do 2 pi minus the pi thirds to figure out when it's equal to 1/2. So that's where we would go 2 pi minus pi thirds, which ends up being 2 pi minus 6 pi, whoops, no, don't want to do anything to that, sorry, we want to change this one. We want to do 6 pi that's messing this up. We want a denominator of 3. So that's right, 6 pi over 3 minus pi over 3 is equal to 5 pi over 3. So therefore, 5 pi over 3 and pi over 3 are definitely going to be what makes cosine of x equal to 1/2. So we have 2 of our values so far. Now, we're not completely done yet, so you want to make sure you keep following along. The next thing you got to realize is that this number right here, this 2, changes everything. It changes the frequency. That's what we just got done talking about in the previous video. It changes the frequency of how often our cycle is going to happen over a 2 pi period. So this is from 0 to 2 pi, and normally we would say, well, cosine is only going to hit 1/2 twice over that period. But because the frequency is 2, it's actually going to hit it double that. So it's going to hit it, it would hit it at pi thirds, it would hit it at 5 pi thirds. Now again, you got to follow along and see what we're going to do with this. But basically what's going to happen is if we're at pi thirds, because it's actually going to do 2 cycles, pi thirds plus 2 pi, another cycle around. Okay, so actually let me write this over here just so you see it. So we're going to do, we have pi thirds and 5 pi over 3. Our next one is going to be pi thirds plus a whole nother rotation around. Because again, if it's going around the circle twice, it's going to be in this same spot in 2 positions, at pi thirds and then whatever pi thirds plus 2 pi is. Okay, and pi thirds plus 2 pi, again, let's just rewrite this, pi thirds plus 6 pi over 3. That's going to be 7 pi over 3. So there's our third one. And then we have to also do our 5 pi thirds plus 6 pi over 3. And that's going to give us 11 pi over 3. So that does give us 4 angles. But once again, we still have a problem here. And this is why this gets so complicated, because there's so many steps involved. Is this only solves it if it's cosine of x. It doesn't solve it if it's cosine of 2x. So how do we take these 4 angles and figure out what x is going to equal? We figured out what our angle has to be for it to be equal to 1/2, but we did not figure out what our x has to equal. So this part is the easy part. Once we get the initial 4 angles, we're just setting up an equation for each one of these. 2x equals pi over 3. 2x equals 5 pi over 3. 2x equals 7 pi over 3. And 2x equals 11 pi over 3. You're just solving each one of these equations to figure out what x would actually have to equal for the angle to be what they are. So we divide both sides by 2 and every one of these, and we just end up with pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So these are the 4 values of x that we want here. And notice all of these values fit within this domain. All of them are between 0 and 2 pi, so we do have 4 solutions. And you can notice the frequency. Normally we only have 2 solutions. On a regular cosine graph, we would only have 2 solutions in between 0 and 2 pi. But this frequency right here is always going to change that number. If the frequency is 2, then we go from 2 solutions to 4 solutions. Down here, you can probably guess that we're going to go from 2 solutions to 6 solutions. So we will work on this a little bit more in class. I don't want to go too much in detail on it. I'm not going to have you do this one on your own. Okay, we're going to do this one in class. So I will see you then. Sorry about the length of this video.